Welcome back. Here is yet another Algebra 2B lesson. Today we're talking about section 13.5, the law of sines. Law of sines and then 13.6, law of cosines. Very different than all that unit circle stuff we've been talking about up till now. A little bit different. You probably remember this from geometry. It's not that tough. Two things in the law of sines. First of all, you can use sine to actually find the area of a triangle. Here we have this, a sailmaker is designing a sail that will have dimensions shown in this diagram. Based on these dimensions, the sailmaker can determine the amount of fabric it needs. So here we have a base of 2.13 meters and a side length here of 2.96 meters, and this angle here, angle A, is 73 degrees. So the area of the triangle represented by the sail, remember, area of a triangle is 1/2 base times height. We don't really know the height. We could probably figure it out. Although you don't know the value of h, you can calculate it by using the fact that the sine of A is really h over c, or h equals c times the sine of A. So basically what that ends up being is this. The area ends up being 1/2 the base times c sine of A. So if h equals c sine of A, we get this. So what ends up happening is we get this area of a triangle formula. And it works as long as you know two sides and an angle, two sides and the angle in between them, we say that's the included angle, you can find the area. So for example, if I know side B and side C and angle A, I can use 1/2 BC times the sine of A. If I know C and A and angle B, I can find the area by finding 1/2 AC times the sine of B. And then if I have angle C, as long as I know A and B, I can plug them in and find the area of the triangle that way. So three formulas depending on which angle and which sides you know. And depending upon the triangle, we can find missing sides using things like Pythagorean theorem. We can also find missing angles because remember that all the angles of a triangle add up to 180 degrees. All right, so in your note sheet, it's kind of the same thing. They worked out one of the formulas, but again, there are two more. So first of all, we have 1/2 BC sine of A. You could also have 1/2, as I said, AB sine of C, or 1/2 AC sine of B. All three of those work. Just depends on what you know. So if we look here, find the area of the triangle using this formula. We have two sides, 14 and 9, and we have this included angle, 42 degrees. So just plug those in, use your calculator, evaluate it. Now you're going to have to round because that's usually what ends up happening with these sine values because of the irrational numbers and things like that. So we end up getting about 14.2. If I want to do this here, look at, I've got an included angle and I've got two sides. So let's see, angle A is 64 degrees. Side B, doesn't really matter, we'll call that one 6. Side C, 15. Plug them in. 1/2 6 times 15 times the sine of 64. And I would use my calculator. You can just do, let's see, 0.5 times 6 times 15 times sine of 64. Just got to make sure that you are in degree. Go to mode on your calculator, make sure you're in degree, since we're in degrees here. If you were given these angles as radians, you would have to make sure you are in radians. I think the standard is radians, so make sure you go to mode and make sure you're in degree. And then let's figure it out, 0.5 times 6 times 15 times the sine of 64. I usually put all those values in parentheses, and I get 40.445. So I'm going to say about 40.4. For number 2, my angle is 76 degrees. We'll say B is 16 and C is 28. Um, so 1/2 16 times 28 times the sine of 76 is going to be about, let's say 16 times 28 times the sine of 76, about 217.3. And here it's meters squared, here it's yards squared, but that's that. The more important thing here, this isn't even the law of sines. We haven't even gotten to the law of sines yet. The more important thing is this. What is the law of sines? Well, it comes from deriving the area. Since all three of these formulas can give us the area of a triangle, we can set them all equal to each other, and we can solve, and we find this. Sine of A over side A is equal to the sine of B over B, sine of C over C. It's a very simple formula. It's great. So as long as you have an angle on the opposite side, you can basically, what we do is say solve a triangle by finding these missing values. You can use the law of sines. Law of sines is used as long as you have two angles and a side, angle side, or you have angle side angle. It'll also work if you have two sides and an angle that's not between them. So side angle, which we don't normally use with trig, but you can use it with the law of sines. So what do we mean here? If we look here, how do we solve this triangle? We have two angles and a side. Angle, side, right? We got two angles and one of the sides opposite. So I could say the sine of S over S is equal to the sine of R over R. And then I could also find T. That's easy. Just like I said, subtract from 180. And T is 91. So then I can use that to find side T. So I just set up my proportions. The sine of R over R is equal to the sine of S over S. So sine of 49 over R is the sine of 40 over 20. Work it out. Use your calculator. Cross multiply. R is about 23.5. Then we're going to do that same thing. Sine of 40 over 20 is equal to the sine of 91 over T. Work it out. You get T is about 31.1. If we look here, we have an obtuse angle, 141 degrees for E. We've got two sides. We got angle, side, angle. And to find the third measure, we just subtract again from 180. You get D is 16 degrees. So I can say side E over E is equal to side D, sine of D over D, and the sine of F over F. Well, let's see, D is 16 degrees, as we found. The side opposite, side D is 9. Cross multiply, you get E is about 20.5. Do the same thing there to find side F, and that is about 12.8. So that's it. So, and we'll get to the ambiguous case in a moment, but let's take a look at this. So here's another example that's in your note sheet. These proportions are true no matter what the triangle is. It doesn't even have to be, the nice thing is, it doesn't even have to be a 90 right triangle. So here we have angle B is 102, angle C is 53, and side C is 10. So we can find the missing angle A by subtracting from 180, it's 25 degrees. So then we just set up our proportions, and we can find side A, and we can find side B. So here, let's take a look at this example. So we've got this information here. I've got these three numbers. What are they? What I have is angle A is 34 degrees, angle C is 67 degrees, and side A is 12. So we've got these sides. What we have to do is find the measure of angle B first. So I'm going to do 180 minus 34 minus 67, which is 79 degrees for angle B. So now I have all the information I need. I'm going to use sine A over A equals sine B over B. So that would be the sine of 34 over 12 equals the sine of 79 over B. Cross multiply, and you're going to get B equals 12 sine of 79 divided by sine of 34. So I'm going to type that in as is. I'm not going to round until I'm all done. 12 times the sine of 79, or I'm sorry, 79, divided by the sine of 34 is about 21.1. And then I'm going to say the sine of 34 over 12 equals the sine of 67 over C. So then C is going to be that same thing, 12, well, not the same thing, sine of 67 divided by sine of 34, and that'll be about, these are both kind of about, right? 12 sine of 67 divided by sine of 34 gives us about 19.8, 19.75, so about 19.8. And that's it. Now, if we go back to the textbook, there's a problem. So when you use the law of sines to solve a triangle and you know side-side angle, the problem is you may have one answer, you may have two answers, or you may have no answer. It all depends on that angle on the side. So if angle A, if you have side A, side B, and angle A is acute, then you might have no triangle, you might have one triangle, or you might have two triangles. It just depends on where we're at, and it depends on the angle B. So if the length of A is less than the height, you have no triangle. If the length of A equals the height, you have a right triangle, and so you're going to have an answer. If A is less than B, but greater than H, so greater than the height, you have two possible triangles. And if A is greater than or equal to B, you're only going to have one triangle. You want to focus on looking at A and B. So if A is greater than B, you're all set. If A is less than B, then you're going to have to compare A to H to see if you have a triangle or two triangles or no triangle at all. Now, if A is a right angle or if it's obtuse, then if A is less than B, that triangle doesn't exist. If A is greater than B, you have a triangle. So really, you got to look at the angle, and then you got to look at A. So they kind of work it out here. Use the values of A and B in the measure of angle A to determine the number of triangles. If there's one triangle, you can use the law of sines. If there are two triangles, you can use the law of sines to find the measure of angle B and the other measure of angle B. So one would be obtuse and one would be acute. And then you could use these values to find the other measurements of the two triangles. So what does this mean? Well, if we look at this application here, Maggie's designing a mosaic by using triangular tiles of different shapes. Determine the number of triangles that Maggie can form with measurements of A is 11, B is 17, and the measure of angle A is 30. So here's our problem. Angle A is acute, so we have to find the height. So sine of 30 degrees is H over 17. H is 8.5. You're just going to use that. Assume we have a right triangle and say opposite over hypotenuse. Work it out. So this situation, we have height is less than A and A is less than B. So we have two possible triangles that she can create. One where B is an acute angle, that's B sub 1, and one where B is an obtuse angle, that's B sub 2. So first of all, we work it out where side B is 17, like they said. And we get the sine of A, Sine of 30 over 11 is the sine of b over 17. Work it out. The sine of b is about 77.3. All right, so either way, you're going to use this same process. But if b is an acute angle, it's going to be about 50.6 degrees. If b is an obtuse angle, we're going to have to subtract that from 180. We get 129.4 degrees. So this creates a lot of issues, because then the measure of angle C may be obtuse if b is acute, or it may be acute if b is obtuse. So then we got to figure this out for each of them and work out two possible answers. Luckily, in your homework, you don't have to do this a lot, but you will have to look at it for at least some of the stuff. And the key here, like I said, is to use this table. If A is acute, you're going to have one of four possibilities. If A is a right angle, you don't have a triangle. If it's obtuse, you might have a triangle. It all depends on the relationship between side A and side B. So again, if you use example 3 as a roadmap, you can solve these triangles using the law of sines. That's it. I'm sure there'll be questions. Make sure you let me know. If you learned something, smash that like button, and I will see you in the next one.